And so today let's start out just factoring. And here's my illustration for factoring. Let's say you bake a whole bunch of stuff, and you bake...
Stuff?
Yeah, chocolate chip cookies is one.
Cupcakes.
Chocolate cupcakes is another.
Are we just going to say all the things?
You are just trying to make us chocolate.
Those are chocolate chips. And then chocolate cake is another one.
That is not a muffin.
Make a cake with Stuckies on it.
Stuckies are so good.
And a flour. Because that's what I need.
And so you got all these different types of foods. And suppose that when you made them, you used their separate recipes, and they all list some ingredients. Knowing what goes into cookies and muffins and cakes, what are some common ingredients between these foods? Alan?
Sugar.
Lots and lots of sugar.
Mountain Dew.
What else? Lars?
Flour.
There's flour. There's going to be flour in all of them. And John?
Be eggs and all of them.
Yeah, you can make all these different types of baked goods with eggs. Christian?
Chocolate.
There's going to be chocolate.
Chocolate.
Sadie?
Water.
There's going to be some water, some sort of a liquid base.
I got one.
Maddie?
Baking powder or soda.
Baking soda. And Mills?
More chocolate.
More chocolate.
Yeah.
There we go. Extra chocolate. And so, we separated these ingredients from each of these different recipes. In math, when we did the color experiment, Carson, when we did the color experiment, we had each cup had different colors in it. And if you separated out those colors, it's kind of like this. You're taking out ingredients. And all that goes to say that terms in math can be broken down into their separate ingredients. And to break them down, you need to figure out what's being multiplied and what's being divided. In each of these, you're multiplying a lot of different things in a row. This one you're doing 2 times x times y. That one's obvious. This one isn't so obvious because you got to separate the x's, and you got to prime factorize the 6. And it's a lot easier. It will be a lot easier than that sounds throughout the course of this chapter, because I'm not going to give you giant prime factorizations that you just won't be able to do. Most of them you'll be able to look at and see, I know what 6 is made out of. 2 and 3. And then you got 2 x's here, x and x. And then this one over here, right now, if you look back, you have a 2 times a 3 and then a 2. So a common number in all of those right now is 2. And so when you prime factorize this 10, you may want to think, if I take a 2 out of it, then that'll be common between all of these. So 10 and 2, or what times 2 equals 10?
5.
Everybody's waiting for it. X, and then a y and a y. And so now that we look at these 3 terms, what do they have in common? Laura?
They all have a 2.
They all have a 2. What else? Sawyer?
They all have an X.
They all have at least one x. There's one x here. There's at least one here. And then there's at least one here. What else do they all have in common? Anything? Nils? They all have the variable. Yeah, the variable x. Can y be a common factor in this?
No.
It cannot. Why can it not be a common factor?
Why cannot be?
Laura? Exactly. So this is our common factor in all 3 of these terms. And the way that we're going to write this out is we are going to put this on the outside, and then we're going to do parentheses right here, and we're going to pull out the common factor from each of these terms. Okay? I'm not talking exactly the way the notes are written right now, so I apologize for that. But we'll go over and fill all the blanks in on the notes after I do this. And so when you pull out the 2x from each of these, you're removing a 2 and an x. And so over here, remove a 2 and an x, you have what left?
Y.
You have a y.
One.
Remove a 2 and an x from this. What do you have left? And from here?
5.
5,
Why?
y, which I'm going to write as y squared. You have factored this statement. The blanks for number 2, when factoring,
I think it's nifty.
It sure is.
when factoring is the first blank, divide out the common number.
Okay if it's sideways.
When factoring, divide out the common number and or, yeah, that's cool, and or variable.
Nothing.
In A and B, under the examples, I wrote them out just the different terms without adding or subtracting. And so when you write the factors, the common factor for those three, or for those two, you're just going to write factor, colon, and then write the term next to factor that's common between all of those. So what variable and or number is common between 3x, 5xy, and xz? Maddie?
X.
X. What is the common factor between 5x, 10y, and 15z?
5.
Tyrese?
5.
Factor is 5. Alright, and now we get to the part where we actually have to pull the factor out and then rewrite the first equation on the inside of parentheses with the factor divided out. And so we have 3x, 6x squared, and negative xy. What is the common factor between those? Lars?
No, I don't know.
Maddie?
X.
We have an x present in all of them.
No, but it's a negative X.
You could write it negative x. If you write positive x, that means you're going to be dividing away just positive x. If you write negative x, you're going to be dividing away negative x. And the inside equation will change depending on what one you do. But all you have to do in this circumstance is x. And so you divide out an x, and so what's left over inside? We have 3x. We take away an x from 3x, which leaves us with what?
2X.
There's
Oh, 3. Sorry.
3. You take away an x from 6x squared. What do we have left?
6x. Oh, 6x.
6x. And take away an x from
XY.
xy?
Minus y.
Minus y. There you go. Let's see. So we are on letter D, and we have a common factor in all these terms, but it's not just a number or just a variable. There's a number and a variable. Can anyone see, just by looking at it, what that common factor is going to be?
2x.
Anna?
2X.
So you're saying that there's a 2 and an x present in all of these terms. So what do we do once we pull out a 2x? What do we do to these three terms to put them in the parentheses? What is the process? Tyrese?
Let's see. Minus 2x from all of them.
Close, not minus, but you divide the 2x away from all of them. Yep. Thank you, Tyrese. So you divide each of these by 2x, which means this one just has a y left over. This one, 4x divided by 2x, is just going to leave you with 2, so minus 2. And then this one, 6xz divided by 2x is going to leave you with 3z.
Okay.
3x squared y plus 3xy squared plus 3xy. What is common in all of these three terms? There's a number and some variables. And there's a 3, there's an x, and there's a y. You know,
X plus Y.
okay, go ahead.
There's X, there's still one X.
There's one x left there.
And there's one Y left, and there's nothing left.
There's one y. Nothing. This is the curveball. This is the trick. He said that there's
One.
nothing left. What happens when you divide 3xy
One.
by 3xy?
Oh, it's one.
It's 1.
I know there was going to be
X
a 1.
plus y plus 1.
I told you there was going to be a 1.
F.
That was a given. That was a given. Why are there birds?
And so, in this term and in this term,
Oh, really?
what is the common factor? Think outside the box. Think outside.
You're not supposed to distribute?
No, don't. Distributing would be going forward, not backwards. Backwards is factoring. James?
Is it X plus 2?
X plus 2 is the common factor. And the way you write it is this. You write x plus 2 in front. And then you leave the other stuff in parentheses next to it. X and 3 are left over. Isn't that crazy? I'll color coordinate it for you. Suppose that,
No.
like in the last problem, no, in this one, x squared plus x to the third. What's common in all of these terms? Down here? There's at least an x in all of them. And so you have an x out front, and then on the inside, you have the rest of it with x divided out. So you have x plus 1 plus x squared.
You're so color coordinated.
Now up here, the term that we wrote in front was x plus 2. So that's what goes in front. And then what's left over here when you take away the x plus 2? X. And here? 3.
3.
So x and 3.
Oh, that makes more sense.
Good.
Got it.
So close, so close.
But yet so far.
The last blanks. Factoring by grouping. On your homework there will be a section called factoring by grouping. Which means you should draw a line, and here's your blanks. Draw a line down the middle. And so if we have
What's grouping?
3x plus 4x plus 6y minus 3z, draw a line down the middle. Where's the middle?
Plus. The middle plus.
That one?
What?
So draw a line straight down the middle,
That's not.
factor this side,
Nine.
then factor this side. So over here, 3x and 4x, what's the common factor?
3
That is X.
minus 1.
Laura, x. And then 3 plus 4 in the middle. Actually, this one, you could have just combined similar terms, but for the sake of factoring, we're just going to go with this. And so 3 plus 4 would end up being 7, and you would have 7x. But over here, you have a common factor. What is that? Emily says 3. Do you agree?
Yeah. I like to eat.
Because you said
Everyone likes to eat.
you went and said
When you divide away 3 from 6y, you get 2y. When you divide away 3 from negative 3z,
you get
you get
4
negative
z.
z.
Stop, you should be a rabbit.
So what goes in the blank?
Maybe I am. So the blanks filled in say, draw a line down the middle, factor the left, then the
Right.
I'm gonna walk around the room. If you guys have questions, great.
Sam,
Not
we're gonna hall.
say pass or something.
Pass, Magnum.
Quick thing about the